49 years ago, Apollo 11 blasted off from Cape Kennedy, Florida. Its target, 384,400 kilometres away, the Moon. American astronauts, Commander Neil Armstrong, Commander Module Pilot Michael Collins, and Lunar Module Pilot Edwin Buzz Aldrin Jr. are strapped into a command module atop a 7.6 million pound thrust space vehicle, travelling at an average speed of 7,400 metres per second. The Apollo 11 mission is considered one of the greatest achievements in human history. It continues to inspire generations of youth worldwide to dream of reaching for the stars.
All right, again, ladies and gentlemen, welcome. Thank you so much for joining us today for Space 2.0. Do you know that it's actually 49 years ago this week that the Apollo 11 mission blasted off? They were actually on their way to the moon as we speak. I'm giving away my age a little bit here, but it was such an exciting event. It was monumental, and it certainly changed the course of human history and indeed technology. It was the beginning of this very exciting phase of humanity and human endeavour in which we live right now. So we're going to hear more about that and where the space industry is at in just a few moments' time. But to officially get proceedings underway, will you please welcome Richard Barrett, who's the Director of Facility Creative Industries for TAFE Gold Coast.
I'd like to respectfully acknowledge the traditional owners of the land on which we meet, the people of the Coomera Nation, and pay my respects to elders past, present, and future. Thank you and welcome for coming. We're really excited that we could host this event at Queensland Coomera, and we hope that you get a lot out of it. Thank you for those of you that have attended in person, and of course those that are participating online. So enjoy. And have a great day. Thank you very much.
Thank you, Richard. On July 1st, the Australian government finally got its act together and launched our very own space agency. This is the head of our space agency, based in Canberra, Dr. Megan Clark.
Well, great to be part of Space 2.0, even though it's virtually. In terms of space industry at the moment in Australia, it's roughly just under a $4 billion industry in itself, but of course space enables almost every aspect of the broader economy in terms of its use of space, and we can talk a little bit more about that. If you come back to the space industry itself, almost 3/4 of the industry is in the communication and data download area. So think of direct-to-home TV, data communication. So it's a big part of how we communicate. Then we also have areas such as the ground station, so our linkages from Earth to space and from space back to Earth. And for us, that's about an 8% sector. We have high-tech industries, so we have a very healthy and quite encouraging high-tech equipment area in Australia. So these are the main areas that we have in the space industry, and of course we're looking to grow those. Well, when we did a review into the capability of the current Australian space industry, one of the recommendations of that review, which was completed and given to the government, was to set a target of growing that space industry to a $10 to $12 billion industry by 2030. In terms of the Australian space industry, we think we could even be a bit more aggressive than that target that was set by the review, because we are seeing quite a strong growth, and we do want to grow Australia's proportion, how we're represented in that global space market. So we're currently looking at that, but we think we might be able to set an even tougher target for the country.
Dr. Megan Clark, ladies and gentlemen. Just for your information, you're not the only audience here today. We are talking about technology, and thanks to the wonders of 21st century technology, this event is being streamed around the world, and we will be taking questions from people who are tuned in or plugged in or jacked in or however you want to term it throughout the course of events. Before you meet our panel for Space 2.0 this afternoon, I want to introduce you to their boss. His name is James Gilmour. He's the co-founder of Gilmour Space Technologies. They're only just up the road here in Pimpamar, and they specialise in low-cost hybrid rockets. Very exciting synergies that they've already established with the US in particular, with NASA, and I know the US military were interested in their 3D fuel printing as well. Very, very exciting what they're up to, and to tell you more about what Gilmour Space Technologies do, will you please welcome James Gilmour.
Thank you, Trevor. Hi, everybody in the audience. Nice to meet you guys over in internet land. My name is James Gilmour. It is such a pleasure to be here. TAFE is such an integral link in the academic landscape and an important fundamental input, I think, to a range of capabilities that I'll talk a bit more about later. Our company have had a number of engagements with TAFE, and this is just another way that we can support. Big thanks to Karen. Big thanks to all those involved, Richard and whatnot. I'm going to talk a little bit about what we do, where we want to go and how we want to get there. And I am quite privileged to be able to share with you some of our bright young individuals that, with their tireless pursuit, are working on some game-changing technologies that is going to have domestic and global impact. We right to go to the slides. Gilmour Space Technologies, headquartered in Pimpamar, Queensland. We have about employed about 21 people, and we're supported with a small office in Singapore. How are we going with the slides? Oh, beautiful. So what we've got here is just a bit of a snapshot about the domestic space industry. That photo that you guys might see there is from a recent CSIRO 2.0 event. And I guess when my brother and I started this, there was only a few players in space, involved in space technology in Australia, and it was hard to see the forest through the trees. Now there's just over 50, and it's just great to see some of that change. We tag it as a space renaissance, or a fundamental shift in the way people do things with regards to space technology. I'm going to talk to you a little bit about how people can get involved, because perceptions is 9/10 the law, and you don't just have to be a rocket expert or a propulsion engineer to get involved. Next slide, please. So some of the areas of focus that these companies are dealing with range from IoT, Internet of Things, that are affecting agriculture, mining, oil, and gas. There's Earth observation, a number of those companies and universities that are doing satellite manufacturing, which is really exciting. But for us, what underpins all of that wonderful stuff that those people are doing is access to space. Next slide, please. So this is just a little bit about our company. So we're a hybrid rocket company. We design very advanced hybrid motors to support the underserved small satellite industry. And we're currently going through a testing regime. You guys might have seen our most significant milestone to date with a very large static test fire of our orbital class vehicle, and that will be the backbone of our propulsion program. So this is just a quick snapshot. The one on your left is a traditional liquid engine. Just by looking at it, there's more pipes and instrumentation that you can poke a stick at. Our mantra is to design for cost, and the one on the right is just a snapshot of a recent test fire. We don't have many moving parts. Our oxidizer you can store at room temperature, and that mixed with a solid component, and we're starting to get some really good results. Hybrids were explored, I guess, in the 80s and 90s, and people weren't successful in that. But like the Colonel has his secret herbs and spices, so do we. So So a bit of a case study in terms of the array of, skill sets that are required. This is just a case study from, another light launcher vehicle called Rocket Lab, principally based in New Zealand. Next slide. They have a range of skills that are required. This was just from recently from their website. Over 200 employees are required, ranging from STEM-based areas of focus through design, through project management, through security, through IT. So this is just a bit of a case study that you don't have to be a propulsion engineer to look to get involved in the space community. And I think TAFE has a tremendous opportunity to be able to support that and filter in some of that skill set that's required. Next slide, please. So, next slide. So this is a little bit about where we want to go. So we launched our first rocket on the 22nd of July 2016. That was the first flight test motor of a 3D printed fuel grain, and that was our catalyst to secure venture capital money to support our program. We're currently on a testing regime. In about 3-4 weeks, we'll be doing another major test, and that, hopefully, if that goes well, fingers crossed, everybody, please, will be another milestone, and subject to that being compliant, we'll be going on to a flight campaign, and subject to regulatory approval, launching at a very far location, some 1,700 kilometres away, the end of October. Next slide. In terms of some interesting areas of focus, Jeff Bezos wants to do manufacturing in kind of low Earth orbit. Elon Musk wants to go to Mars. In terms of a point of difference, we think that it'd be good to get back to the moon. Part of our, if you see on our logo, which my little niece designed, is to launch from Australia to Moon, to Mars, and to the stars. But there are a number of other areas of focus in terms of in-space propulsion, space mining, space debris mitigation, deep space missions. All these are going to require a tremendous array of talent for people to plug into. So you don't have to be a rocket scientist. You can go to TAFE, and there's going to be jobs for people who come out of TAFE. You don't just have to go to uni. I think it's such an important part of the landscape. So enough from me. You're going to hear with some of our actual bright young stars who are going to tell you a little bit about what they do, and they're going to ask some Q&A. So just again, thank you for everybody involved. Thank you for the audience for coming involved. Please check us out on Facebook, Twitter, and on the internet, and to the stars.
Thank you, James. In just a moment, you're going to meet those bright young stars of which James referred at work at Gilmour Space Technologies. Before we go there, a couple of things. I mentioned that we've got people that are watching this event online, and for those who are jacked into the web around the planet, the address, it's a Skype address. If you go to space2018@outlook.com.au, you can message us with your questions, and we will endeavour to do our best to answer them. That's space2018@outlook.com.au. Before we meet our panel, one more virtual guest that I'd like to introduce you to. Absolutely brilliant working in the field of AI. She has founded a company called Spaceport AI. Her name is Dr. Natalie Rens.
Hello, I'm Natalie Rens. I have a PhD in neuroscience and currently work as artificial intelligence specialist with the Office of the Queensland Chief Entrepreneur. And I've also very recently founded my own space company, Spaceport AI. So our broad mission is to enable sustainable human life in space. We're very young, but for me, what I would love to be able to do is to create an entire, basically, center that's dedicated to space innovation development. We're covering human systems, autonomous systems, and sustainability. And I think because of that, we can actually partner with a lot of different companies here. So we can partner with companies that aren't technically related traditionally at least to space, so like resource companies. We can also partner with startups. So we've spoken a lot, obviously, with Gilmour Space Tech and some of the startups that are also down south about how do we, for example, create autonomous launches, autonomous rovers. So, yeah. I think for me, space is this very extreme design case where it's really pushing us to do the best that we possibly can in terms of our design and scientific and engineering knowledge. And the reason that we choose AI is because it's essentially the most powerful tool that we have today. It's something which I think will enable us to augment the capability of the humans that we send off on these first long-term, long-flight missions, especially when, for example, we might only have 100 people on the BFR that Elon Musk is creating. And you have those 100 people trying to establish an entire settlement. So if you can use AI in different aspects, such as the autonomous rovers that will build the colony, or you can think about smart hothouses that can actually respond and adapt the climate according to what kind of stage of growth the plants are in, or smart biometric suits that can predict ahead of time medical events. I think it's basically up to your imagination what you can actually use AI for. When I was young, I actually wanted to run off into the Amazon rainforest and find new cures for people, so research the plants and collect them up and gather them. And because of that, I went and I studied biomedical science at university, but I realized that actual pharmacology is more about graphs and metrics and like this entire idea about exploration. So yeah, I always was fascinated by space, and I'm a massive Elon Musk fan, so I followed it over the last few years, and I've got the SpaceX t-shirts and sat during my PhD and watched the launches. But for me, space was always this realm of engineers, and it wasn't something really tangible for me. I came from a very different background and my own skills, and it was only very recently that it occurred to me that I could actually get involved in this, and so I'm doing it. I did all the traditional subjects at high school, so English, mathematics, and all of the sciences. And then I did biomedical science, a master's of cellular molecular neuroscience, and finally a PhD in neuroscience at University of Queensland. I would say they're not actually directly relevant to what I do. So a lot of the work that we're doing, I get to jump in on research, and I get to use a lot of those skills that I've developed. But I think at the end of the day, what that taught me the most was just the ability to learn and this really massive passion for learning. And if you then jump into a new field like space and you're suddenly having to face new challenges, it means that you can tackle anything. I think the best thing you can possibly do with your time is that you can spend time finding your own passions. I was only first year of PhD, having spent my entire, let's say, life from the age of 10 thinking that I would go and be an academic. And it was only during that time that I suddenly realized, oh my gosh, I don't want to be an academic. And it was because of that I then had to really spend a lot of time investing in things that just seemed more interesting to me without having this clear plan. And it's brought me in about 2-3 years to this entirely different space, which I could never have predicted. And it's only because the things that I found that I was really passionate about, I gave everything in learning them. And so I think even if you're interested in space, but you're really good at design work, you can find ways nowadays. You could create virtual environments, for example, that will help astronauts maintain their health. That would be my advice, is to follow that. And then obviously for us, if you're interested in AI, then maths and coding is always going to give you great kudos. So, yeah, I think if you're interested in space, go for it. If you have that passion, if you're really committed to the dream that we can actually make this happen, then I think that's more important than anything. So, at Astra. Yeah.
Dr. Natalie Rens. In just a mere matter of seconds, ladies and gentlemen, you will meet our fascinating and rather brilliant young panel of guests for Space 2.0. Thank you for your round of applause. I'll introduce the panel to you. In fact, I'll get them to introduce themselves. Firstly, to my far right, Jay Craig. Let's hear Jay's story.
Okay, so my name's Jay. I'm a software and electrical engineer at Gilmour Space Technologies. I'm doing full-time work here and full-time uni at QUT. My degree is Bachelor of Engineering, major in Aerospace Avionics. I graduate this year. My primary role here is a software engineer with a little bit of electrical on the side. I do all the software for our data acquisition and the control of all of our hot fire testing. And I'm also doing the front-end interface and a little bit of the back end for our ground control station for our launch upcoming this year. Last year, I went to an industry night at QUT that was held. Gilmour Space Technologies was there. They presented just a brief, like, this is what we do. Didn't know they existed before then. I spoke to Jamie, who was there. I got subsequently work experience from that. And then after my 3-month work experience, I got a job here. So I've been working here ever since.
Thank you, Jay. Great. Our second panellist is Nick McLean. Let's hear from Nick.
Hi, so my name is Nick McLean and I've been working here since about July last year. I graduated from UQ with a Bachelor of Mechanical Engineering and Physics, and I've been working mainly in propulsion teams since then. We work on quite a bit of stuff. All of us here work on a variety of different things, so you have anything from mechanical design to kind of chemical experiments, I guess. I've been working on 2 main projects, the catalyst development, and this recently is our new 3D printer that we've been using to print a basis for our fuels and a lot of our molds, so it's been really exciting stuff. So the 3D printer allows us to rapidly alter designs as well as quickly mass produce fuel grains and any kind of new parts we want. We can print quite a large area. Not many places in Australia can print to this capacity, so it's a really unique capacity that we have here, and it's been really good for rapidly changing designs and saved us a lot of money in terms of mold creation and fuel grain printing. Our big thing here isn't about reusing things so much as it is making it as cheap as possible, and this allows us to make things vastly cheaper than if we went through getting these things machined for every part. You go through solid propellants, and liquid propellants have a lot more complexity with how you have to design around them. Fortunately, with our things, you can just rapidly produce parts that don't need to be as robust.
That's Nick McLean, and our third panellist is Kristin Stewart.
My name's Kristin Stewart. I graduated with a Bachelor of Science in Physics, and here I do a lot of work with simulations of the trajectory of our vehicle and looking at the aerodynamics of the vehicle as well. Okay, well, we're in our factory where we're putting our rockets together. That's why it's a bit messy at the moment. I work up in our office upstairs where I do a lot of the simulations on the computer, but here all the guys fabricate our rocket and our motors that will get us up to space. Yeah, my key role is in the simulation of the trajectory of the vehicle. So with that, we look at the range safety. So when we launch a vehicle, how safe is the downrange area? So is there any chance that some asset will be hit or anything like that? So I do some analysis in that area. And then also on the aerodynamics of the vehicle, so predicting how it'll react in flight at the speed that we're going, really.
And our fourth panellist is Jacob Sheehy.
So my name is Jacob Sheehy. I'm a propulsion engineer here at Gilmour Space Technologies. My primary role is to design the propulsion technology that will take us to orbit. So I studied a Bachelor of Mechanical Engineering at QUT and graduated in 2015. It's been something that I've thought about a lot as a young fella, and was really interested in space, but the interest sort of died out as I was getting older because there was no opportunities to really be involved in space in Australia. But when I heard about Gilmour Space Technologies, I jumped at the chance to work for them. So I've been at Gilmour Space Technologies for 2.5 years now. Pretty much from the start of the rocket program, I've worked on all of the motors that have been designed so far in the company.
Ladies and gentlemen, please welcome our panel for Space 2.0. I have to ask you all, just as a first up question, are you all sci-fi fans? Are you like nutters like me? Is that how you get interested in space in the first place?
Yeah, huge sci-fi fans. Doctor Who all the way. Yes. I think Nick will agree with me there. Big Doctor Who fans.
Yeah,
I think there's a prerequisite at Gilmour Space Technologies to love Star Wars. It's very fun. Both James and Adam really big Star Wars fans.
Does that include episodes 1 and 2?
Yeah.
Pretty dodgy.
All of them. Any
and all. Heated debates about both the prequels and the new ones.
I bet there are. And what about you, Nick? Are you a sci-fi fan? Yeah.
Yes.
Yeah. And Star Wars or anything else?
Yeah, Star Wars. Never got into Star Trek or anything like that. Star Wars.
Okay, so my intro totally bombed with you. There's no resonance whatsoever. Okay. And Jay, what about you?
Yeah, Star Wars. I think the first question that I got asked from James when I first started was Star Wars or Star Trek? Yeah, I said Star Wars. So.
And as budding young scientists and engineers, just on a Star Wars note, 11 parsecs, that's not actually a distance, is it? No, it doesn't mean anything?
It's a unit of time, right?
Yeah.
Is that right, Kristin?
Oh, well, this is going back to university days. But yeah, they did get it wrong in the movie. It's hotly debated ever since, I'm sure, but yeah.
So it's a unit of time.
I think it might be a unit of distance, and he says in the movie I did the run in 11 parsecs, but it's a unit of distance, so it doesn't mean anything. Yeah. And then in the latest movie, the Solo one, they kind of tried to fix that up. Pretty sure they made some offhand.
And they bombed.
Yeah, it did.
Okay. So beyond having the interest in sci-fi, when did the idea of a career in space or the space industry first take seed with you?
For me, I think it was sort of in primary school. Like I said in the interview earlier, the interest was there all through primary school. Then going through university, I sort of, through high school, it sort of died out. To actually have the opportunity to work in the space industry in Australia is very limited. So I sort of lost interest in that and was more looking towards engineering and mining and that sort of thing. But to then have the opportunity to work for a space company in Australia, I couldn't be happier to actually, have that opportunity and be able to do it now. It's sort of like coming straight out of university into a dream job.
Yeah. But you've been on board with Gilmour for pretty much since the start, haven't you? So before that, what options were there in this country?
Yeah, nothing really. I mean, to work for a big defence contractor on smaller components like upgrades and that sort of thing is sort of the only real space application that you could possibly have, but otherwise it was having to go offshore if you were wanting to work in the space industry.
Right. And Kristin, what about you? Were you, at what point did you think, I want to work in this industry?
I think I was much the same. Probably in mid to late high school, I really took an interest in astrophysics and cosmology.
Don't we all?
I think it started with reading through a bunch of the old space magazines, but I guess I went through high school hoping that I could do something in astrophysics. And then in university, I did do numerous subjects in astrophysics and cosmology that really kind of piqued my interest. But I was still kind of at a loss to where that kind of research would be done in Australia. And then I happened to stumble upon really Gilmour Space Technologies, which was really a fantastic opportunity for me that kind of just showed up. So I was lucky enough to get an internship with Gilmour Space, and from there kind of take on board some of the more, physics-related aspects of the engineering.
Wow. So before you became aware of Gilmour, were you thinking maybe I have to go offshore, that was going to be the only option for you?
Yeah, it really was. It was kind of either I go offshore or I change what my interests are and keep, to be honest, I thought astrophysics would really just be a hobby for me for most of my life, and physics would be something that I could pursue as an actual career. So an opportunity to actually pursue something related to astrophysics as a job was really not open to me in Australia before finding Gilmour Space Technologies.
Wow. Jay, and what about you? When did you first start dreaming the dream?
Well, I mean, it's pretty similar to Jake and Kristin's story, but I never really expected to get a job in engineering. I didn't really find the interest until about 2 weeks before I had to apply for uni. I just sort of picked engineering as something that sounded cool. But I always had an interest in space going through primary school and high school, just about how big things are in space and you know, stars and black holes and all that stuff. But I never really thought I'd work in the space industry. I definitely knew through uni and school that there was pretty much no opportunity in Australia without working for a massive contracting company. So I was prepared definitely to move overseas. But luckily, during sort of the later years of my uni, I went to an industry night and heard of Gilmour Space Technologies on the Gold Coast nonetheless. So
yeah, as you said in your filmed introduction. And how exciting is it to be a part of that industry?
Oh yeah, the fact that, you know, the difference between working here and working for a big contracting company is your responsibility, and the responsibility that each of us have is far greater than it would normally be in a job like this. So, but obviously that comes with challenges, but the rewards are
scary and very exciting.
Yeah. Do you feel like that you're sort of pushing the boundaries of, you know, space, the final frontier sort of stuff? Or is it the final frontier?
One step at a time. Yeah, but I mean, I feel like we can definitely make a decent contribution to the space industry with the technology that we're developing at the moment.
Yeah,
for sure.
Yeah, I'm sure you're already well on your way, as we've heard. And Nick, for you, I know that when you were studying, you worked for the defence industry and you worked, I think, for an energy company. Yep. Did you think that you would be able to go into the space industry?
Yeah, not really the same kind of thing. I was a huge physics nerd in high school. I had this whiteboard in my room and I used to try and like make equations to how you create a black hole and that kind of thing. I wasn't very good at it. I didn't make any. But I always got frustrated because you'd see like there's like conventional rockets. You look at how we're actually going to get to like distant stars. We can't really achieve that with current technology. And so I always thought something like a wormhole. I don't know if anyone's seen Interstellar, but they do that. They go to like Jupiter and they go through a wormhole. I thought that would be like the only way that you can actually get to interstellar travel. So I was focused on that for ages, not in any career way, but I really liked the idea that that could be possible. And then when that wasn't, my math didn't work out. I kind of lost interest in that part of physics for a while. And then when I went and studied physics first, and then started engineering about halfway through, mainly because I found I did a physics project, and I find they have they go very specifically into one research area, and they often lose sight of the bigger picture. And that's not to say that's all physicists, but it's often the case in a lot of careers, physicists' careers. And I saw with engineering, there's a scope for you can work on larger projects. You see the bigger picture, and you can you do the physics, the fundamental physics can still apply, but you get to apply that to a bigger thing. And like Kristin was saying, there's nothing like working in space is the only way. I think that you can, you get the fundamental physics constantly applying to everything you're doing, which is frustrating because it's a lot more complicated than just iterating another problem.
Sure.
So you have to create a new solution every time. And we have to always go back to the fundamental physics. And that's why it's good we've got people like Kristin who know it better than us. And then Jay and I can be like, yep.
Well, I wasn't making any wormholes when I was in grade 10 or the maths for it. But yeah, I think Nick is right. Working with someone like Gilmour Space, it allows you to apply a lot of those fundamental things that normally wouldn't be utilised in like an engineering, and I guess maybe your average engineering career. So it's a really exciting opportunity for using that knowledge.
Okay, great. Okay, well, look, I know that we have many guests here today and probably busting at the seams with the chance to ask their own questions about careers in space. So can we take a question from the floor, please?
Hi there, everyone. I'm Jonathan. I get to work with students as young as about grade 3. I'm in a space-focused problem-solving program. And I actually got to visit the academy about a year and a half ago, which was fascinating actually now to see how much success Gilmour has had, even in that short space of time. What I'm really interested to ask you guys is, obviously there's a lot of technical skills, and it's fantastic to hear about your background, especially engineering, physics, etc. But I'm really interested in what you might think are the bigger picture skills, so even beyond that, that helps you succeed in the problem-solving side of things, really, for what you're trying to achieve.
Yeah, so I think in that regard, the idea of working as a team seems quite simple, but it's complex to actually work as a team with someone and usefully do that. And I think the way that you best think through a project is to have different points of view on the problem that you have. And I think that's a big thing, aside from the technical aspect, is working well with other people. And I think the team that we have at Gilmour is very good at doing that, and I think has contributed a lot to the success of the company. So I think, that'd be a key area for me. Like, there's no way that you can do this thing by yourself, like just trying to work through the problem by yourself all the time. You're always going to want a fresh perspective on things, look at how things can be done differently, how things can be done innovatively. It's I think a really key skill that's more of a social skill than anything. That's my opinion.
Well, I guess on that note, a big thing about working in teams, something we do a lot of, is people have strong opinions on things, and that's not always a bad thing. Sometimes it can be, but you have to almost remove your, if you want to call it an ego or something in the scenario. So if you have a point of view, you really have to look at it very factually. You have to kind of approach every problem with what is the best solution. It's not necessarily my solution, but you kind of have a round table. And we often have like really heated discussions about things. They're not like aggressive in any way, but you want to have the right solution, and you don't want to have like this, it would be better to vocalize an opinion, even if it's wrong, than to say nothing. And that's what we try and do a lot of. So we get everything reviewed a lot of times. And as a young company, that's really important for us as our team. We go, I'm constantly saying to Jacob or Kristin, hey, can you check this? Does this make sense? And if they say, no, don't do that, we'll talk about it. And that's a big thing. So it's not just like working in a team is, anyone can work in a team, but to work well in a team is, quite a challenge.
That's interesting points that you make. Traditionally that kind of idea that geeky scientists are very much in their own zone, and yet you're talking about having social skills, working as a team to resolve issues. That sounds like that it's a really essential trait almost to achieve success. Would you say that?
Yeah, definitely. We have one guy who's brilliant. He did a master's in the US, and he's done a lot of our subscale testing. And when he started, he found that was a big thing for him. He was like, big learning trait was that working in a team, and the other thing was trusting other people. So he knew that he could do this task well, but he couldn't do these two tasks simultaneously. So he had to learn to trust other people to do it. And he said that's like been a huge growth for him. I think we've all had a lot of that development, going from being, we all trust each other inherently in a lot of things, so, which is good.
Great. We take another question from the floor. Oh, sorry, anything else? You're okay? Yeah, could we take another question from the floor? Yes.
Hi there. My name is Damien. I'm a recent graduate from a Bachelor of Mechanical Engineering from QUT. I started working down in Melbourne, but found it wasn't, as we said, as technical in terms of the aerospace industry, and decided to come back up to Brisbane. I'm currently deciding whether to go into a PhD or whether to continue pursuing an industry-based experience, and was wondering two things. Do you think a PhD is worth it when coming to companies like Gilmour? And secondly, what type of mentorship or support do you guys get along the way in coming up with the solutions to what you're working on?
Good question.
Thanks.
Yeah, I think it's kind of debatable, I guess, for the PhD aspect there. None of us have a PhD, and we're working with Gilmour Space, so it really depends on where your interests lie, I think. If you're, I don't think it's necessary, is what I'm saying, to have a PhD to work in the space industry. But if following those research methods is something that you're passionate about, and there's a particular subject you want to explore in detail, then I think it's definitely something that's worthwhile, particularly if that research area can apply in the space industry that you want to pursue a career in. I think it can be beneficial, but it depends on your level of interest in actually doing the research.
Yeah, I agree totally with that. Like if you want to just go and do PhD for the sake of doing a PhD, then don't bother, in my opinion. If there's something that you're keenly focused on, something you have a massive interest in, then definitely go do it. If there's an application to industry for that, that's even better. But yeah, it's my opinion that if you're doing a PhD for the sake of doing a PhD, then you're not going to be as driven to, I guess...
Do well in it.
Yeah, do well in it, yeah.
And you do learn like a different set of skills. So there's people often compare it to like if you did a few years doing your PhD versus a few years in industry. If you did a few years in industry, it depends on the company and that kind of thing, but you would learn probably a wider array of skills if you worked in industry for 3 years compared to working on your PhD. But that doesn't mean that it's the right choice based on that. I don't like that argument. I'm just pointing out that you'll probably hear that a lot. People will say like the time spent, but you can, in 3 years on your PhD, as Jacob said, if it's something that you enjoy doing, or if it's an area of research that you think could be a career, like if you were doing electrical engineering or something, you wanted to focus on RF, radio frequency research, there's a lot of that in Australia. So if you did a PhD in it, it wouldn't just be a PhD that doesn't go anywhere. It's a PhD that will always be relevant if that's your career that you want to do. If you don't know what career you want to do and you're doing a PhD, that's pretty risky, because then you might have a PhD that you spent 3 years on that you don't apply later. And that's, I guess, a question for you more than us. So,
yeah. I think part of the question you asked was about mentorship as well. Do you guys get inquiries from students or people outside the sector that are very curious about what you do and how they might get involved? And if so, what's the process there? What kind of relationships do you have?
We've got a lot of not young students, but university students and high school students who come and do internships with us. And James and Adam are both they advocate that a lot. And it's really great to have them come in for, say, a month or so and get a taste of what working in the space industry is really like. And then as for the mentorship part of it, being a young team, it's kind of, it's good in a way that we help each other a lot. But I guess we don't have a, we don't have a set mentor at the moment, but James and Adam are both very passionate about it, and through their passion they mentor us to achieve more in our roles, really, and it really is a huge motivation there. But they are also very interested in getting more for us in terms of mentorship throughout the space industry in Australia. So finding people who could be helpful to us, not just in our roles in our jobs at Gilmour Space, but just throughout our entire career. So that has really kind of taken off for us, and it's hugely helpful.
So it's not just about Gilmour per se, you guys want to see the industry foster and nurture it as much as you possibly can. It's in your best interest.
I think the Australian Space Agency is exciting for that reason. Like, Gilmour can succeed and hopefully will, but the Australian Space Agency is something that will be here forever, hopefully. But that's a gateway for lots of industry to start up, and I know James is the same. We aren't against having other launch providers in Australia or even internationally. We don't see them as they are competitors in the sense we'll be after the same kind of clients and everything, but we can all survive. We can all work together, and that's the more industry there is, the better. Even for us, like it means we can work with them, we can partner, and we can prosper.
I think someone on the floor had a question about rocket labs in New Zealand. Someone got that question. Do we have that person here? Someone was asking about rocket labs in New Zealand. Do we know who that person is? We might be able to find them in a moment, but I know there was a question about that, so we might get to that in a tick. If you're a Mac or an iPhone user like me, you'll be all too familiar with the voice of Siri, which, by the way, is an Aussie, in case you don't know. Her name's Karen Jacobson. In just a moment, you're going to meet the voice of the woman who answers the commands and the queries of the astronauts on the International Space Station.
Hi, I'm Andrea Boyd from Australia, and I'm standing in one of the mission control centres for the International Space Station, where my day job is as Eurocom. So I'm the person that talks back to the astronauts and interfaces between space and the mission controls to run several hundred experiments each day on the International Space Station. Growing up around country South Australia and looking up at the stars was always really fascinating for me, and I wanted to know more and understand it more. And then I watched Star Trek and learnt the word engineer through my teenage years, and decided if I picked a degree in engineering, then that was the way that I could make things like spaceships work, at least according to Star Trek, which is more or less how it ended up working out. I studied mechatronic engineering at the University of Adelaide, with part of it completed at Yongnam University in South Korea. So it was quite good as a mechanical and electronic and computer systems, and then I was able to specialise in space in later years with that degree. But when I graduated, there wasn't really anything in Australia. It's nothing like the landscape is now. So I was looking to Europe for work. If you wanted to work in America, you had to have American citizenship, and I wasn't so interested culturally either, whereas Europe, I'd lived there before during high school and during a couple of my gap years during uni. So I was really interested in getting back to Europe and possibly the European Space Agency. Unfortunately, there was a misunderstanding a little bit with degrees because over there they do bachelor masters, and over in Australia we usually do bachelor honours. So I had the option of doing another degree in Europe or working for enough years and then coming over as a professional engineer. So for me, it ended up, I had a really great job offer with a company in Australia in a different industry, and I had done work experience with them, really liked it. So I stayed with them for a few years and ended up working in FIFO mining, which I also loved. I loved it so much I almost didn't leave actually, but after the amount of years were complete, I took the chance and had prepared quite a lot in advance, applied for a few things in Europe, had interviews set up. So I bought a one-way ticket, quit my job, went over and sat the interviews for the space industry that I'd been after for so long. And thankfully my first interview straight off the plane from Australia, I don't recommend that, worked out quite well. And 7 years later, I'm still here. So the right amount of experience in either engineering or a science degree plus real-world experience helped a lot for the space industry for me. But I think in Australia now, because we have so many amazing companies that are around and we have a space agency, it'll be a lot easier to go even straight from being a graduate engineer into the space industry, and in Australia as an option too.
There you go. Andrea Boyd, from mining engineer in the outback to the flight controller at the European Astronaut Centre. Quite extraordinary. I guess that comes back to what Andrea was saying. She's talking about bringing practical skills into the industry and having a career outside of that. What pathways do you guys see for people who perhaps aren't, physics geniuses or, engineering freaks that can go down that path? There's got to be plenty of other employment opportunities for people with other vocational skills, for instance, that would be studying at TAFE, for example.
Absolutely. I think some of the people we work with, some of the fabricators, are significantly smarter than us in terms of design and as an example, we often go back to this first principle approach with designing anything, and some of our fabricators will just say an idea and they'll be like, oh yep, do it like this, this, and it's like, oh, I wish I could think that quickly. So there's definitely a path through fabrication and anything, I guess. You can become a really good designer just through hands-on experience. So a big crossover we have with space is the automotive industry as well. So if you've worked on cars and that kind of thing, it definitely helps. There's a lot of dualities between the two industries. So I'd say there's not really any, I'm trying to think, I guess in creative arts is probably one that doesn't directly apply to space, but pretty much any other industry or any other, I guess, educational route can lead into the space industry. There's a huge market for that.
Yeah, actually I've met a guy who was a former mechanic for the V8 supercars, and he's now working for Elon Musk's SpaceX program, building rockets in California. Just pretty amazing. What other careers can you guys see that could eventuate for people not coming from a science background, for instance?
I can take over from Nick and sort of answer your question as well. I think from my background in software, programming is a huge industry in rockets. I don't think people really realise how much software and coding and programmers there is in space, but you can build a rocket, but if you can't control it when it's going there, or anywhere, then there's no point. So there's like, how many millions of lines of code was on the shuttle. How many developers would that need? A lot. You don't necessarily need a degree to code. I mean, there's tons and tons of programming languages that you can learn. There's heaps of tutorials online on, various languages. And I guess that ties into AI as well. Like, maybe we don't directly use AI at the moment, but AI is all programming. So any experience in that is highly valuable. And I think experience is one of the most important things you can do. I think 2 years experience on a resume beats a PhD most of the time. There's just so many things that you learn that you wouldn't necessarily learn if you weren't, in the industry, talking to people every day. Getting on different projects that you're not necessarily focused on. For example, I started the company as a software engineer, solely to do data and control, but there was an opportunity to do the electrical systems, the wiring, the design of it. We were, tight for hand, so I put my hand up and said, I've got a bit of downtime from my software, I can do that. And I learned a lot of things from a few other people that we work with, just about, designing in general, but more so having a secondary skill as well to apply. So I think that was extremely valuable. So my take on skills is, software programming at all. It's a really handy skill to have in the space industry.
Jacob, what about you? I mentioned that you've been with Gilmour for almost since the start. What changes have you seen even in 2.5 years where you're seeing people coming from other areas now that are coming into the sector?
Yeah, so I guess as material science is advancing, there's a lot of composite work coming in as well. And, the operating composite machine, like filament winding machines, CNC machines, that sort of thing. Nick and myself actually did training on the large 3D printer that we have, which is pretty much like running a CNC machine. So that's another skill set that we have been able to pick up through the job, which has been really interesting to learn. And it's, I guess that from a vocational learning side of thing is something really handy. Fitters and turners are always going to be required in machining metal components, and also the operation of all that equipment. So people from, I guess, the boat building industry and high performance car industry, like you said, are applicable to the space industry as well.
Yeah, like space itself, the opportunities are endless.
Yeah.
Almost, yeah.
I guess also on that, I just had a different thought, was that it's not necessarily just the jobs that you can work on in the space industry or building rockets or satellites. There's a lot of industries that will kind of couple in. So Jake and I visited the CSIRO in Pullenvale. They do a lot of electrical robotic stuff. And there's a lot in robotics and I guess the integration of mechanical and electrical systems, which is pretty much all systems now. It's like your laptop, anything like that, drones, all that is mechanical electrical systems. So anyone working in those industries can partner with space companies. It doesn't have to be you go and apply for a space company. You could work at a robotics company that works then with us or works with another space company. Like the guy who gave us the 3D printer. He started off in his garage just building 3D printers and developed it up to a company he now has, and he's from the States. So it's that classic, started a company in his garage, and then now he's making them and mass producing. So I guess what I'm saying is that you don't have to look at SpaceX's or Rocket Lab's list of open vocational positions. You could look elsewhere and just think, hey, this is equally cool. There's lots of cool stuff that applies just as, I guess, things branch down from the space industry.
I think anything in STEM is probably a good place to start. But now that Australia has a space industry, I think the jobs are just going to exponentially grow in every field, not just engineering and science. But yeah, I think Australia's just waiting for that backbone support. And then I think there'll be a lot of startup companies and bigger companies looking for space, graduates or job applications in the coming years, definitely. So I think it's going to be a thriving industry.
So how much of the federal government's initiative to start our very own official space agency will kickstart that along, do you think? And you'll see more companies like Gilmour, for instance, starting up.
I think it'd be huge, really. It's not just the propulsion side of things, but all of the other uses for propulsion, really, like all the satellite businesses starting up. Those kind of like communication industries, I think will likely be really boosted by the Australian Space Agency and just generally support for a space industry in Australia.
Yeah, okay. Can we take some more questions from the audience? Do we have another question from the audience?
With the rise of like the asteroid retrieval mission and NASA and the possibility of these really involved long-term missions, how do you think that affects the industry going forward, especially as someone who might be looking to get involved in it? And is there anything that really stands out to you as like a surprising lesson or something that separates an individual in your industry from a similarly skilled individual in another industry?
I think for us, it's not really a trait that's unique. It's just our biggest thing is tenacity. So if you're like determined to do something, if you have a project that you just want to like, this is answering your last question, sorry, we can maybe go on to the other one. That's a bit trickier. But our biggest thing is just like, everyone in our company is driven to achieve whatever we set our minds on it, whether it's a small project or a large project. And there's a lot of, like, we all learn the skills as we go. Like, we've got a basis in university, but you learn a lot as you go, and you teach yourself what you need to do. So you don't have to come in with an amazing skill set. You just need to be really driven. And that's why our work experience program and our internship program, which is why James is such a big fan, you get people to come in and work for maybe a couple of months, and you see that. You see it immediately, whether they're determined to just like, this is their single focus. And that's why we have this issue, obviously, if you've got some people with single focus, having that work in a team. And somehow we've got it. It's rare, I think. But yeah, so I guess teamwork and tenacity are the two big things that, well, I personally look for. I don't know about the other guys, but yeah, fairly sure it's pretty broad. So.
Yeah, I think this touches on what Nick's talking about with teamwork, but communication skills was something to me that was surprisingly needed, mostly because the things that we work on in like, say for me, something I work on in looking at the trajectory of the rocket can be quite specific, and though it relates to everyone else's field, it's quite hard to communicate the specific needs or requirements of what I'm doing to how these other guys might need to think about it. So being able to think about your own work in relation to how it takes on with other people, and then communicating that to them is really a skill that I found was surprisingly important. I guess it seems kind of obvious to say you need good communication skills to work well in a team, but it really kind of dawns on you when you try to talk about one particular thing, assuming that everyone would know what it is, but oh, well, no you don't, because that's something that I spend all my days working on, but say Jacob wouldn't, so it's, yeah, it is needed.
Yeah. Can we have another question from the audience?
Your current minimum estimate for kilograms to orbit is $25,000 per kilogram, and that's about 10 times the amount that it is for SpaceX, and almost the same it is for the shuttle, or same it was for the shuttle. Do you plan on using any form of reusability or partial reusability or refurbishability in the future?
I guess the plan for that is to make the rockets as low cost as possible, with the intention of mass producing rockets. So the ideal concept with hybrid rockets is that they are far simpler than liquid rockets and far safer than solid rockets. And I guess the difference in price for a very large launch vehicle to a smaller launch vehicle is obviously that the amount that you can carry is more, so that you can charge less. It's like anything buying in bulk, you save money on it. But for the small sats, I think being competitive in the small sat payload mass cost is our initial aim. And then moving forwards, we'll look at reducing cost on the larger scale. But touching back on the mass producibility side of things is like the difference between a liquid rocket, there's hundreds of moving parts in a liquid rocket. With the solid rocket, there's very few moving parts, but the propulsion system is very dangerous, like having the fuel and oxidizer mixed together at all times is potential for explosion, having voids in your fuel grains, potential for explosion, that sort of thing. And then hybrid sort of takes the best of both worlds in that you are able to have the oxidizer as a liquid and the fuel as a solid, and can only get combustion when they're actually mixed. So it's not until you actually mix the hot oxidizer with your fuel that you can get combustion. So it's intrinsically safe in that the system is totally reliant on having those two propellants mixed. With the mass producibility is basically in the solid fuel side of things, and us looking at the advantages of additive manufacturing and 3D printing, that sort of thing, is what we're hoping. And what we're hoping is going to significantly reduce the costs compared to other companies who use more complex or more dangerous propulsion technologies.
I think also on that note, there's this misconception that we're competing with SpaceX or Blue Origin or NASA. There's the difference between large launch providers and small launch providers is kind of like, I think it's not well understood in the sense that large launch providers often, they will send large payloads in, say they might send a module to the ISS or something like that, and that's a specific trajectory that they will send it on. If the launch vehicle has full capacity, if it's sending, say, let's say it's sending a defense contract, it's working on a defense contract, it has to only send that defense satellite, and so the cost per kilo, if it's the same, it's just the launch. So let's say the defense supply weighs 500 kilos, but the capacity of the rocket is 1,000 kilos. They're now paying double per kilo because they have to pay for the whole rocket. The other thing is, each time you launch a rocket, there's this kind of, the other misconception is that all orbits are equal, which Kristin knows very well, not. So there's a variety of different orbits that you'll want specific, you'll want for different specific purposes. So in our case, the small launch providers like us and Rocket Labs, we're targeting the capability to launch for specific clients at low cost to their specific orbit. So they don't have to go to SpaceX and say, hey, can we put, so if you went to SpaceX now and you said, I want to put this CubeSat on, it's nothing. It should cost 10% of what we charge. But you have to go through a contractor who then puts this into another bundle, and then you have to get set to whatever orbit they're going to, which means you're restricted by their deadline. So if they're not scheduled to launch into your orbit for another 3 years, then you have to wait those 3 years. In our case, what our most direct, I guess, comparison is with Rocket Lab, who are charging, I think it's 45 to 50,000 per kilo. That changes, and ours might as well as we get closer. But the fundamental difference is that with large launch providers, they're not looking really to service the small market. They might in the future, in that case we'll adapt. But at the moment, there is a distinct difference between those two industries. It's like comparing Mercedes charging $150,000 for a car versus $30,000 for a Kia or something.
Rocket Labs, Nick, you've mentioned it a couple of times. James mentioned it before, and there was a question that came through about it, which was, do you have a relationship with Rocket Labs? And what's the difference between what Gilmour does and what Rocket Labs do?
Yeah, so I can't really comment on the relationship we have with them. That's probably above me. But the difference in technology is the simplicity, I guess. They've gone the conventional route of having a liquid bipropellant motor that they use electrically powered turbo pumps to feed the oxidizer and fuel into the combustion chamber. Like I was saying before, with the hybrid technology is much simpler, and specifically the means of pressurization that we use to feed the propellant into the combustion chamber is simpler as well, in just a pressurized gas feed system. So yeah, I guess primarily the difference is the core technology between us and Rocket Lab. There's obviously the stage at Rocket Lab and the stage that we're at is vastly different at the moment. So, I'll be very interested to see when we're closer to the stage at Rocket Labs that the things like differences in cost and differences in performance with a company like that. Yeah.
Okay. In getting back to our virtual guests, we did ask the head of Australia's Space Agency, Dr. Megan Clark, if there are any skills, qualifications and/or careers that are predicted to be the most needed by the Australian industry as it grows. This is what she said.
It's a great question, and to all the students, really, it's very, very open, but let me just start with just a few examples. If we think of space as a critical node in the way that we are going to communicate and the world is going to communicate and the next generation of data, then anything in the area of data science, communication, and those techniques as well, not just in the radio spectrum, but in the future we will be using lasers. So that whole area of communication will be extraordinary. And the question I would put to the students is not just what the job is, but think of what you might do with the next generation of bandwidth that we will see from space. So already in trials, we're seeing 13 terabits a second being able to be achieved in trials in Germany in terms of transmitting data by using light. So the question I would put to students is, imagine what you might be able to do with that. That's being able to download everything that's ever written in 30 seconds. So let your imaginations go wild on how we will use data. But there's other areas we're going to need more medicine, not just healthy on Earth, but healthy in space and on Earth. Space tourism will grow, so the whole medical aspect of working in remote areas will grow. Australia's just revised its space law, and other countries will need to follow suit. The US has just advised that they will need to upgrade their laws and regulations to modernise these laws and regulations to really fit in with the development of technology, low Earth orbit satellites, small sats, microsats. So the area of space law is one that is growing, and Australia actually leads in that. And then the broader use of space. I mentioned we're not just looking to grow the space industry itself, we're looking to grow the broader use of space. And that comes into almost every aspect. So students don't feel restricted to just the space industry. Think of if you're in agriculture, how are you going to use space to automate what we do in agriculture? How are we going to operate in our offshore oil and gas platforms? How are we going to use robotics and robotic technology and rovers on Earth, but how are we also going to do those in space? So this, when you think about it, the application of space to everything that we do on Earth is going to really broaden up, I think, the opportunities for roles. What the students can do, of course, is be that conduit into these industries of saying, hey, this is what's happening in space, maybe we could use that. And as I said, it goes across every sector. When you think of just the way we position ourselves in space, we do this all the time with our phones, and when we look at sort of Google Maps, Australia is now going to have world-class capability of 10 centimetre accuracy anywhere in our Earth, on the landmass, in our maritime and in our airspace, but we're also going to have 3 centimetre accuracy through Geoscience Australia's work in our cities, which means we can now automate our vehicles. So, I tried to really outline there's just a very wide range of jobs and areas that students can consider when they think of space.
Interesting, so many possibilities. Kristin, I have a question for you, because we've just heard from Dr. Megan Clark. She's the head of the Australian Space Agency. Earlier we heard from Dr. Andrea Boyd. She's the flight operations engineer for the International European Space Station. Dr. Natalie Rens, she's working on AI applications for the sector. I just love that these prominent industry figures are women. Does that suggest that the industry is not dominated by a bunch of blokey cowboys in search of the final frontier, to requote Captain James T. Kirk?
Yeah, it is really exciting to see a lot more women interested in space and just STEM in general. It has obviously been rare, I guess, and myself, I'm quite surprised to see so many in it today. It's really inspiring. I think it's still needed. Like going through uni myself, I did see a fair amount of girls in physics, but I also dabbled in some of the engineering subjects, and there was less women in that area. And it's really key. I think, female and male bring different kind of aspects to the workplace and different skills. So it's really helpful to have both sides of the coin, really. And it's great to see that it's kind of actually starting to pick up in the industry these days.
Fantastic. Okay, if I could ask each of you, because we're just about to run out of time here, if you had one piece of takeaway advice for anyone who's considering a career in the space industry, what would it be? Jay, what would yours be?
Probably two things, which kind of answers this guy's question about the future before as well. One, don't give up. When I was I know it's cliche, but the first couple of years of uni that I did, I failed a lot of subjects. It wasn't easy for me to transition from high school to uni, but because I'm so stubborn, I just did the subjects again, and I didn't give up, and here I am now, finished all my subjects almost with my degree. And the other thing is just try and motivate yourself, I guess. Read, keep up to date with everything that's in the space industry. I'm reading Elon Musk's book at the moment of how he started Tesla and SpaceX, and it just gives you a fresh perspective. Like every time you read a couple of pages or see a nice news article that Rocket Lab or anyone just did a successful launch, it really hits home that this is what we're doing as well. This is what I can achieve. And make sure you have a list of goals that you want to achieve in the future. I know a lot of people who don't really, spend time to do that, but they also don't really, move forward, I suppose, in what they want to achieve, I guess. Do I want to do this in 3 years? Do I want to be working at a space company next year? What do I need to do to achieve that? And no matter, what happens, just don't give up on it. Make sure you keep trying to hit those goals, even if people tell you, no, or if you get rejected for a job interview or whatever. Just learn from it. Ask yourself why did that happen? What can I do to change that or fix it next time? I think it's, pretty important.
Fantastic. I think you could take that advice for just about any career, but yeah, definitely.
For
sure. Nick?
I'll do the same and say that it's not, I won't give space-specific advice. I think if you just do what you enjoy. If you enjoy working in space, if you enjoy working on, even if you just enjoy working on problems, or you enjoy working on something that's bigger than yourself, then space is the perfect industry for that, no doubt. But if you enjoy it, people, I guess, have this another maybe misconception. We don't sit around at computers all day, stern-faced and bored. It's a very light workplace. Everyone's enjoying themselves. It's hard, it's difficult, but ultimately we're all happy doing what we're doing, and I think that matters more than what you accomplish or what you try and do. If you just enjoy doing it, then the rest will come easily.
Great. Kristin?
I guess advice for getting into the space industry from me would be to try and communicate with as many people in the area as you can, starting with university lecturers or TAFE lecturers, and then just not being afraid to email whoever you can find that's in the industry and bug them until you get a response, really, because everyone in the industry is excited to have more young people in it and to be able to share their experiences. So I think that's it's definitely a stepping stone, just to be able to put your name out there, get someone interested in you personally, and hopefully from that you can look at building a career in the industry.
Yeah. And Jacob?
Yeah, I'd probably stand with Nick the most. I agree with Kristin and Jay as well, but I think as long as you're interested in what you're doing, you'll do well at it. If you're not interested in the job that you're doing, then you're not going to enjoy your work, and you probably shouldn't do it. You probably shouldn't be there. I mean, if you want to actually, make a meaningful contribution, then you should do something you enjoy because you're going to do well at it.
Great. Ladies and gentlemen, the clock unfortunately has beaten us, but before we go, make sure you check out the mini expo outside the auditorium here. There's an actual Apollo 17 spacesuit there's a rocket as well out there. I thought it was just a high-tech espresso machine. I got all excited there for a moment. But really worthwhile having a look at that. And by all means, take the opportunity to introduce yourself to our guests here today. Kristin's just mentioned that. They're here now. Make the most of it. Introduce yourself and find out a little bit more about it. Get their email address, start pestering them and follow your dreams. If I could just say this thing that, often when we're faced with a particularly tough challenge, it's said that it's not rocket science. Mm-hmm. But today, that's exactly what it was. And our very knowledgeable guests have brought that one step closer to reality. So could you please thank not only our panellists, but James Gilmour and our virtual guest today for being a part of Space 2.0. My name is Trevor Jackson, and I'll leave you now with one last piece of footage from that monumental Apollo 11 mission. Thank you.
Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. We have a liftoff. Liftoff on Apollo 11.
Shadow. 4 forward, drift into the right a little. 30 seconds. Forward drift. Contact light. Okay, engine stop. Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're going to be busy for a minute.
Armstrong is on the moon. Neil Armstrong, 38-year-old American, standing on the surface of the moon. On this July 20th, 1969.
That's one small step for man, one giant leap for mankind. Oh, that looks beautiful from here, Neil. It has a stark beauty all its own. It's like much of the high desert of the United States. It's different, but it's very pretty out here. Beautiful view. Isn't that something? Magnificent sight out here. Magnificent desolation. Tranquility Base, Houston. Guidance recommendation is pings, and you're cleared for takeoff.